We're going to solve some exponential and logarithmic equations. I've chosen, I think, about 7 of these different equations, just different kinds, just so you can see some varying techniques. The first one I chose for you is an exponential function, an exponential equation. And the main thing when you're solving these is you're going to try to get your exponential part all by itself on one side of the equation. So I'm going to move the 14, I'm going to move the 3, and then I'll have the e to the x all by itself. And your goal in solving an equation is to make it read x equals whatever at the end. Okay, so I want to get x all by himself. So I'm just going to start moving junk over. I'm going to add 14 to both sides. I'm going to have 3e to the x equals, looks like 25. I'm going to divide both sides by 3 and get e to the x equals 25 over 3. Next thing I'll do is I need to get this x out of that exponent. And how I'll do this is I'll do the opposite of e, is I'm going to natural log both sides. So I'm going to natural log the entire side. And when I do that, the natural log of e to the x, using our log properties, is x equals the natural log of 25 over 3. And I'm done. And that's the first one. This would be your exact answer. You could push the buttons on your calculator and get an approximation, but this is your exact answer. Alright, this one has the same feel to it as the previous example. I just chose this one because it had a 3 instead of an e, and I thought, well, it might look a little different to you, so I'll choose to do one like this. I'm going to divide both sides by 8. My major goal is to get x by himself once again, so I'll get that 8 moved over to the other side. I'm going to have 3 raised to the 6 minus x equals, and then I'll divide both sides by 8, so I'll get 5 on this side. At this point, in order to get the x out of the exponent, just like I did previously, I'm going to log both sides. Now, I have a choice. I can natural log both sides. I can log base 3 them. Really doesn't matter, just as long as you are logging both sides. So I'll natural log both sides. Really doesn't make any difference, because what happens when I do that is I can bring this exponent out front using my properties. So I'll have 6 minus x multiplied by natural log of 3 equals the natural log of 5. I'm going to divide both sides by this natural log of 3 so that I'll have 6 minus x equals the natural log of 5 divided by the natural log of 3. I'll subtract 6 from both sides, and then I'll flip-flop the signs because my x is negative, and I end up with x equal to the natural log. Let's see, I'll just go ahead and write the 6 out front because I'm going to flip-flop these signs, minus the natural log of 5 over the natural log of 3. And that's what I'll get. That'll be my exact answer for this particular problem. Another exponential equation. This one is set up as a quadratic, so I'm going to solve it just as I would any quadratic. And I'm going to try to factor it first. If it doesn't factor, I could use the quadratic formula. It would be a bit messy, but doable. And e to the x times e to the x. You add exponents when you multiply, so that is e to the 2x. And then I'll need, I think, a minus 4 and a plus 1 to complete this factoring. So let's roll on with this. I've got e to the x because I want to know what x is. E to the x plus 1 equals 0. I need to solve that for x. Then I've got e to the x minus 4 equals 0, and I also have to solve that one for x. Not quite done yet. E to the x equals a negative 1. Now I can't raise e to some power and have it equal a negative number, so this case is not valid. And then I have e to the x equals 4. I'm going to natural log both sides in order to figure out what x is. Get that x out of the exponent. And at which point I'll just have an x on the left-hand side equals natural log of 4. Now sometimes on these quadratics you might have one answer, 2 answers, or no answers. You'll just have to kind of be sure and check them as you go. Here's another one that might look a little bit different, but once you get into solving it, it's going to be very similar to the others. I will get this denominator over onto the other side by multiplying both sides by that denominator, in which case I'll get 400 equals 350 times 1 plus e to the negative x. And the next thing I'll need to do is distribute that 350, move over my constant. So I've got 350 plus 350 e to the minus x. I'm going to move this 350 over, subtract 350 from both sides, and I'll have 50 equals 350 e to the minus x. I'm going to divide both sides by 350, and I'll have 50 over 350, which I believe will be 1 over 7 equals e to the negative x. I'm going to get x out of the exponent by doing the same procedure that I've been doing. I'm going to take the natural log of both sides, in which case I will then have the natural log of 1/7 equals negative x. So then x is going to be negative the natural log of 1/7. And you could actually say that this is a negative exponent and bring it out to this negative exponent. Make it look a little bit simpler by saying x equals the natural log of 7 over 1, or the natural log of 7. This is called a logarithmic equation, and I still need to get this x equals. That's my whole goal, and the x is sitting deep inside of this log. So I need to do the opposite of log, which is an exponential. So I need to do what's called exponentiate both sides. So since this is a natural log, I'm going to exponentiate with e as my base. So I'm going to have e raised to the left-hand side equals e raised to the right-hand side, which will then yield me the square root of x plus 2 equals e. And I could have reasonably taken this square root of and made it a 1/2 and pulled that out front. Really is not going to make any difference. I'm going to get the same thing either way. So whichever way you choose to do this would be fine. But I'm going to square both sides so that I then have x plus 2 equals e squared. And then I'm going to have x equals e squared minus 2. You will need to check each of your answers in your logarithmic equations, because I can't take the log of 0 and I can't take the log of a negative number, and you need to make sure that you don't have that case occurring. So you will need to check your answers, and if you check this one, you'll see that he works. Now I chose an extremely messy looking equation. This is a log equation. I'm going to use log properties to combine the right-hand side into one big lump. Remember that expansion and contraction that we did prior to this? This is subtraction, so it's actually division in my log world. And now that you have the log of this thing equals the log of this little dealie right here, you can say that you're exponentiating both sides. You can say, well, I've got the log of this equals the log of that. This and that must be equal. However it is you want to think of it, you go right ahead. The end result will look like this right here. In which case, I'm just going to solve this one as I normally would if I was given this back in chapter 1. I'm going to multiply both sides by x plus 1 times this x plus 5. So I'm going to go ahead and multiply that out. I've got x squared plus x plus 5x would be plus 6x plus 5. Multiplying it all the way out equals some x minus 1. Bringing that nonsense over to the other side, I'm going to get x squared, and then I'll have a plus 5x, and then add 1 is going to be a plus 6 equal 0. Okay, this is going to give me that x plus 3 and x plus 2, all right, equals 0. Not done yet now. You might want to be, but we're not. So let's scroll this sucker down a little bit. X equals -3 and -2. Now I need to check these very carefully because when I substitute a -3 and a -2 back in to my original up here, get my original back up, I want to make sure that I don't end up with a negative number. So when I go to substitute in this, let's say -3, I'm okay on the left-hand side, but on the right-hand side, I run into a serious problem because -3 minus 1 is a -4, and I can't take the log of a -4, so that one is out of there. Same thing goes whenever I try to plug in a -2. That little sucker's not going to work either. So this particular problem has no solution. Nice. Alright, another little groovy logarithmic equation. I'm going to combine this left-hand side using my log properties. I've got subtraction, so that meant we've got division here, and it's going to equal 1/2. I'm going to pull my same trick that I did last time and exponentiate both sides. This time I'm going to use a 4 as my base, because if I use a 4 as my base, that's going to make the left-hand side just equal x over x minus 1, which is pretty groovy. Right, and 4 to the 1/2, that's the square root of 4, which is 2. Solve this as I normally would any equation. Multiply both sides by this x minus 1, distribute this x minus 1, I'll have x equals 2x minus 2, and I'll bring the x over, bring the 2 over, and I'm going to end up with x equals 2. Very nice. Once again, I do need to check, make sure that this is going to work. Plug a 2 in here. Log base 4 of 2 is 1/2, minus, plugging my 2 in here, log base 4 of 1 is going to be 0, so this sucker checks out. He works. And there's you a few examples of exponential and logarithmic equations.